previous videos about the Graaff generator, I showed you how I made it. That was the very first one, and talked about the importance of relative humidity and grounding the discharge, grounding the bottom corona brush and grounding your discharge electrode. And then the next video, we looked at measuring the polarity with an ordinary voltmeter of the charge collection sphere, how you can do that. And then we did a video on this acrylic cylinder here in guard. I did a video showing running it with and without that guard, and also the importance of the size and shape of the discharge electrode, how that can affect the size of the sparks you get. We also looked at using the original 12 gauge stranded copper wire corona brushes, not touching the neoprene rubber belt and touching it, to see what difference that made. The last one we did was the effect of, or trying to use carbon fiber brushes for the discharge, for the corona charging brush on the bottom and the corona charging brush, or really probably discharging brush at the top. So they did work, but we ran into problems if they rubbed the belt. Now in this video, what I'm going to do is look at the importance of the triboelectric effect. The way this thing is made is I've got a nylon roller at the bottom and a nylon roller at the top. And originally what I did is the nylon roller in the bottom, I used black electrical tape to build up a crown shape on it. A crown shape on the rollers helps keep the belt centered. Then I covered that with a PTFE coated fiberglass tape to get a Teflon surface to get the triboelectric effect between that Teflon surface and the neoprene rubber belt. Now I measured the polarity and found out this was positive relative to ground doing that. Now in this video I'm additionally going to look at putting the Teflon, using a different Teflon tape. This is a different type that I bought. You're going to see how well it works. But I'm going to put it up here. I have the nylon roller down there. And we'll see how well that works. Will this become negative relative to ground? I don't know. I think it might. And so that's what we're going to look at. Okay, another thing I'm going to do in this video is we started out with just stranded copper wire for corona charging brushes. And then we tried the carbon fibers for corona charging brushes. In this video, I'm also going to take a look at using a stainless steel wire mesh for the corona charging brushes. Should work, but I haven't run it yet that way, so we'll see what it does. Okay, I'm going to show you what I'm doing differently with this Graaff generator. You know, I had that big mess after using the carbon fiber brushes. When they rubbed the belt, they disintegrated and got all over it and made a big mess. They worked before it touched the belt. So what I'm doing now is I'm going to try to use a stainless steel wire mesh brush like that, both top and bottom. I'll have them can't see it here, it's in the back there, one there and one there. I've also moved the Teflon tape wrapped roll from down here to up here, but used a different type of Teflon tape. This was the original, it was PTFE coated Teflon coated fiberglass. This is a different type of PTFE tape. It's supposed to be a PTFE tape. It's got some kind of attached to some kind of silicone rubber or something, not real sure, but anyway, this is what I have on there now. So it used to be down here with this tape, now it's up here with that tape, and I'm going to be using that stainless steel wire mesh brush, where originally I had this stranded copper wire brush with a neoprene rubber belt. Well, because my glue joint making up the new neoprene belt came apart, I decided to go ahead and put a natural latex rubber belt on here. That I cut this out of that sheet I showed a little clip of. I bought this natural latex rubber sheet. It's roughly 1 foot by 3 feet long. So I'm cutting 2-inch wide strips out of it. If they're not long enough, I'll have to glue them together. That shouldn't be a problem. Super glue usually works good on rubber. Okay, I've got black electrical tape, a little thicker in the middle. If you look carefully, you can see it's got a little crown in the middle relative to the edges. That should help keep the belt centered. Now I'm going to put the Teflon tape on top of that. Okay, I've got the Teflon tape on it. It's PTFE, which stands for polytetrafluoroethylene. There's another type of Teflon called fluorinated ethylene propylene, maybe some others, but I used PTFE coated fiberglass before down here. This time I'm using this particular brand of PTFE Teflon on this roller up here. We'll see how it does. Now it's really slick. Hopefully this belt will adhere to it enough to turn it without just dragging on it. We'll see. And so we're going to crank this thing up and see if it'll work. Now the whole reason for moving the Teflon covered roll up here was to see if the polarity would shift. I measured a positive polarity on a charge collection sphere originally with that Teflon down here and just nylon roller up here. Now with the Teflon up here, and we'll see what happens. Okay, as you can see, it does work now. Not as big as sparks as I would like. What I'm going to do now is use the voltmeter or the voltmeter and see if I can measure a negative or a positive polarity at the top. Okay, if you remember from our video where we checked the polarity of the charged collection sphere, when Teflon was down here, it was indicating positive. No plus or minus sign on this voltmeter means it's positive. A negative sign means it's negative relative to ground. I've got the common grounded to the same ground the corona brush is. So that it should tell us. We can't go ahead and touch it because there's so much voltage it would destroy the voltmeter. So we're not going to do that. We're just going to get close. Let me see if I can zoom in a little bit more here so we can see that voltmeter a little better. And we'll see. Okay, let me turn it on. We'll see what we get. Okay. It definitely goes, it tends to be just negative anywhere around here with that running relative to ground. Doesn't surprise me. And when I bring this probe here closer to the sphere, it gets more negative. So definitely putting the Teflon tape up here made this charged collection sphere negative relative to ground, where when the Teflon was down here, this was positive relative to ground. Also, it is working with this Teflon tape here, where originally I used this. Okay, you can see the video on the left is with the Teflon coated roller in the bottom. The charged collection sphere is clearly positive. On the right, Teflon covered roller on the top. The charged collection sphere is clearly negative. Very interesting. So it definitely makes a difference if you put the highly electronegative material like Teflon on the bottom versus the top. We can see in these video clips that in this particular case, where we had nylon roller at the bottom, Teflon covered roller at the top, it appears that the charged collection sphere is negative relative to ground. Originally, I had Teflon at the bottom, nylon at the top, and the charged collection sphere appeared to be positive relative to ground. Kind of makes sense because of the difference in triboelectric properties. Exactly how all those charges are being deposited on the belt, the corona brush, and so forth, It's a little confusing, but there definitely is a difference. It's one thing we can say from this video, that it depends on where you put your, Teflon's electronegative relative to the rubber belt, meaning it wants to hold on to electrons. If we put that up top, it definitely makes a difference compared to the bottom. So anyway, to me that's very interesting. I hope you found this interesting. If you did, please like the video and subscribe, and check out our other links and other videos. And be looking for more of these types of videos. We're going to do some more experiments with the expanded Graaff generator and some other things. Now, Google's Gemini says I'd be better off with copper brushes rather than stainless. They said it says copper wire mesh will discharge electrons easier than stainless steel. So I might try that next. So thanks for watching. We appreciate it.